In these examples, you want to find the set or sets to which the real numbers belong to. Now in Algebra 1, we are only going to deal with real numbers. So that is automatically a set. So for every problem that we give you, you should write real. Now, pi. Pi is a special number. It goes on forever, so it does not terminate, and there is no repeating decimals in pi. Since it does not terminate and the decimal does not repeat, that makes it an irrational number. Now remember, if it's irrational, the only thing that can go with it is real. Now for b, we have -1/4. Like I said earlier, all numbers that I give you will be real. Now, I recommend you starting from the bottom of our interactive notebook, which starts with the natural. Natural starts with 1, and they're non-decimals. They're the counting numbers. Since you could make -1/4, -1/4, -0.25, it can't be a natural number because it's not a counting number, because it is a decimal. So we move up. Next one is a whole number. You can convert it to a decimal, so it's definitely not a whole number. Integer. An integer is only a whole number or it's negative. Since we already decided that it's not a whole number, it cannot be an integer. Now, it is a rational number for a few reasons. We have -1/4. If you convert it to a decimal like I did, it terminates. It is -0.25. It does not go on. Another reason why it is a rational number is because the definition of rational is a fraction that can be written as two integers. So we have -1, which is an integer, and 4, which is an integer. So that's the reason why it's only real and rational. Now, 3.12 repeating. Like I mentioned before, it's definitely a real. Can't be a counting number or natural number because it's not a whole number. It cannot be a whole number because it's a decimal. It cannot be an integer because it's not a whole number. Because remember, integers are whole numbers and it's negative or its opposite. So it can be a rational number. The reason why it's rational is because that decimal, the 0.12 behind the 3, repeats. Technically, we could make it as a fraction if we really wanted to, or if you know that a decimal that repeats is rational, that will be fine.